All right, so we have a piecewise function with three pieces. And if you recognize them, tell me the function family. The first one is, which function family is this? It's linear and it has slope. Does that make sense? So it's going to be like this. Does that make sense? How about this one? Linear, because x is to the first power. But it's negative, and it goes up to positive 5. You see that? And then that one, is that linear? It's a constant, so your value is going to look something like this. Okay? So let's take a look at our student work. Good. We're writing down the equation. Kind of. Let's take a look at this one. Okay. Now, it took me some time to think about it. The first one is 2x plus 0. Class, what is the plus 0 that I'm implying?
The y-intercept.
The y-intercept. So that's how I knew it was this graph here. But this student chose to put an extra tick mark here because I knew that slope was rise 2 up 1. Rise over 1, right? So that would have been up 2. Then they went to this box, which was 1. So they did some kind of weird scaling. Do you guys see this? So they actually graphed it correctly based on their scaling. Up 2, right 1. Up 2, right 1. Let's see if they did this one correctly. 4. So they went up 4, drew their horizontal. And this one, positive 5. See, they didn't use their scale. 1, 2, 3, 4, 5. This should have been right here. Do you notice how they were trying to use their box scale? That would have been 4. That would have been 5 up there. And then there should have been down 1. Left or right? So this fraction confuses students. And so what you have to do is you have to assign the negative. What do you do?
Assign negative.
It could be negative 1 over 4 or 1 over negative 4. Because both of those equal a negative number. Does that make sense? So they could have gone down 1, right 4. Should have been right there. So that would be my slope. Or you can go up 1, left. I kind of stopped because I was saying, well, I need to go 4 to the left. And then I recognized in their x negative values that they actually drew extra tick marks. But they didn't do that over here. Do you guys see that? So if you're using graph paper, I would recommend that each box is just equal to 1. I also recognize that the student doesn't know where the boundaries are. Okay? Let's take a look at another one. So we have 4. If you put your boundaries from yesterday's lesson, notice how they both have a 2 here. So if you go to x equals 2 and draw your boundary, remember this is not an asymptote, just kind of helps us figure out where the graph should be. Inadvertent though. And then I go to 4, and there's another boundary. And basically what this graph means here, let's do this one, because this one's graphed correctly. It's basically saying you're going to go between what two numbers, class?
2 and 4.
It's between 2 and 4. And at 2, do you have an open or closed circle? Open, because it's less than. And remember, this is called a compound inequality. Everyone say compound inequality? Just sign up for Khan Academy. In a compound inequality, there's two inequalities. X is less than 4. Pay attention. And X is greater than 2. Do you see how I had to write that? I had to read it from right to left. Do you see that? And the reason why that's the case is X is greater than 2 and X is less than 4. So that's what the compound inequality. Just think of your compound sentence in English. The dog is red. The dog is small. You can put it together. The dog is red and small. Does that make sense? So I have an open circle, and at 4 you have a open circle because there's no line, right? And this is the piece that the student needed. And then they can go back and erase everything else of the horizontal line. Does that make sense? Okay, let's check out this next line they have here. 1, 2, 3, 4, 5. So they have the y-intercept of 5, which is correct. And then they went left 4. Look, this student assigned the negative. Do you guys see it? Which is correct. Left 4. Uh-oh. Where should I go from here? Where, class? Huh? Rise over run. So they're saying down 1, right 4. This is what the student interpreted as, right? You see it? So to graph this, it should be a rise of -1, which means down, and then run of +4. Running means the x-axis go to the 4, and you're going to end up here. So my graph, let's do that in pencil. Pencil. I'm looking for my pencil. And the student should also, the reason why I paused for a second, you should also recognize that their graph is what? From left to right, it's what? Is it increasing or decreasing? Increasing. It's positive. And you should have a negative slope. So down 1, right 4, and this is between 4 and 6. So if I put another boundary at 6, now pay attention. Let's do this in red. In this graph, at 4, is it open or closed? Closed. Okay, so already here at 4, I already have an open circle, so you'll actually fill it in. And then at 6, open or closed?
Closed.
Now I can connect these 2 points, and I can go back and erase that whole line. Sorry. So this one we don't need. And the last one, 2x. Let's just graph that really quickly. 2x plus 0. So I'm using my pencil. I'm going to go at 0, the origin. I'm going to go up to right 1. So always make your slope a fraction. Up to right 1. Up to right 1. Remember back in Math 4, you learned that in geometry you only need 2 points to make a collinear or a line. At 0, do you have open and closed? So at 0 is closed. Right? You put your pen down. Where does it intercept the graph? Okay. And at 2, open or closed? And then you just go back and clean it up. Let's take our calculators and now I can show you all of this. Let's see if we can put this in our calculators. 2x. Everyone say parentheses? It's kind of weird. It's not a rational function, but I want to show you can actually put this in your calculator. And then when I'm putting the restricting of the domain, you press division. What do you press?
Division.
Now I'm going to do another parentheses. Okay, this is a new calculator command now, okay? So when you put in x is greater than, I need to go to test. Class, where's test? Yeah, so you're going to go to the math button. See how it's in blue? So you're going to press it. And then you look for your inequality. Ours is, remember, I'm reading it right to left, greater than or equal to 0. And then you go back to test, so second, math. You move over to logic, and you have the word and. X is less than 2. Second, math. Right there. And then you close your parentheses. Now, I'm not going to go through all of them, but I just want you to know where those buttons are now. You press zoom, 6. Look, the answer. Do you see how you have some puzzle pieces? I don't know what it looks like. The calculator can tell you. It doesn't have all the answers, but at least it can tell you. Let me graph the rest of them really quick. Parentheses 4 divided by x is greater than 2. And x is less than 4. X, second, math, less than 4. And then here I have parentheses, negative 1 divided by 4. X, who's that person in this class? Alpha, what did you press to get the fraction? Alpha y?
Alpha y equals.
Alpha y equals. Oh, good job, you. 1 divided by 4. Oh no, I want it negative. You just push over to get out of the fraction. Negative 1/4 x. And the reason why I did that is because I don't want the calculator to think that the x is in the denominator. So I don't want it to say 1 over 4x. Does that make sense? That would be bad. Plus 5. Plus 5. Close my parentheses. Divided by x is greater than or equal to 4. X is greater than or equal to 4, and so that's under logic, so you just go over right, press number 1 or enter, and x is less than 6. You ready? I'm excited. Hey. Look, 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 look. It created the roller coaster we needed. So, should you just put this in your calculator, press graph, and then copy it? No. You know I'm going to look for every little point on yours. Very accurate. Okay.